All right, here we are. I'm back. That last video was the audio was screwed up. My wife caught it, and so I had to terminate the stream and restart. It's sometimes these browsers. See, some of this is done in OBS, which is a piece of software, freeware, to do streaming, and it gives me the picture-in-picture and stuff like that. And then another part of it is YouTube, and there's a whatever. Well, sometimes all of that stuff just doesn't work, and I think even my computer sometimes gets screwed up if it sits around too long and it doesn't get restarted. The old school problems, right? These are old school problems. If computer's giving you trouble, just restart it. So I did, and now I'm back. And why am I back? Okay, topic hasn't changed. I want to talk about three things today, and two are related and one is not. And the one that is not is that, I'll get that out of the way first. My wife and I drove an EV for the first time. And I want to talk about that experience. I have a truck. And we don't drive. We don't actually drive the truck, except just around town or really around the neighborhood. And then only seldom. I use it to do construction work and to haul dirt. It's a dump truck. So I haul dirt with it. And, I invest money in it, but I don't drive it much. And we just don't leave town. We don't even drive around town. I have an electric bike, and an 8-foot aluminum trailer. And I'll even use my e-bike and trailer to go to the hardware store and get lumber. If I don't have to drive the truck, I don't do it. But we needed to get to Fresno for some consultation she needed to do with a dentist about a tooth of hers. And I won't go into why we had to go to Fresno. It just happened to work out that way. It's hard to provide providers for the type of procedure she probably needs. We found someone in Fresno. Fresno's fairly close, but I refused to do it without an EV. So we decided to go that route. We've never rented an EV and never driven an EV and never stood next to an EV. So this was going to be a new experience for us. I'm not unfamiliar with electric vehicles because, like I say, I've always ridden e-bikes, so I kind of understand how that works. I wasn't worried about it. So we did some research and we found a Hertz rental operation nearby because it had to be walking distance for me to go pick up my EV. And it was a short walk. It was definitely in the neighborhood. And we signed up for a Tesla just not knowing any better what to do. And they hemmed and hawed and they finally gave us something that's called a Polestar. Polestar. And let me switch screens here. This is a Polestar. It used to be an independent company, Sweden or Norwegian or whatever. And they were bought up either by Volvo or Audi. I can't remember which one. But anyway, we got a Polestar. And I didn't really care. It had decent range. Fresno is 150 miles or so from where we live. And that's pretty far. Even, for an EV, that's getting out there a ways. And, but, this thing had a range of like 250 miles or something. So 150 miles was, perfectly safe. So we checked it out, and I went down and picked it up, and it was a nice car, very nice. I think it's probably classifies as a crossover SUV. It's a hatchback. In the back, doesn't really have a proper trunk. It's a hatchback. It's got some of the SUV features. It was small. For me, it was a little small. I probably wouldn't own a car like this, but for rental, it was perfectly fine. I banged my knees getting in and out a few times before I recognized how to fold myself up enough to get to get in and out. And so it was, after a while, I kind of figured it out. This particular EV, I don't know about others, but it was a little strange to drive at first. even though it drives basically like my e-bike, I just kind of wasn't ready for it in a car. It drives a little bit like an automatic. My truck is an automatic. I can try automatic or manual shift, either one. But it was but it's weird, and it's worth talking about because it was actually kind of cute. I thought it was really cute. It's like, this is strange, but it's strange in a cute kind of way. So it doesn't have gears, of course. It doesn't have a transmission at all, as far as I can tell. It just has forward and reverse, which is the minimum, right? It also has neutral, whatever that's supposed to do. It has forward and reverse. And it has a brake pedal, but you don't really use the brakes. It has what we call regenerative braking. And that means that the motors flip over mode and become generators. And it steals energy from your forward motion or backward motion. It steals energy from the rotation of the tires and the motion of the vehicle. It steals that and puts it back into the battery. So it's regenerative, but it's called braking because when it's stealing from your motion goes away. And so you slow down. So that was cool. And it has brakes, like I said, but you hardly ever use them. So after figuring out how this thing actually worked, I thought that was pretty cool. I liked it. And we went to Fresno, had no trouble. It was a kind of a rainy day, actually. It was Monday, so we had a little bit of a rain front that came through. There's some rain and a little bit of light traffic, not much. And we got there in 2.5 hours or something, well ahead of her actual appointment, which turned out to be really nothing more than a consultation. We have to go back. So we got there, and I guess we went to lunch right away. And after lunch, we still had a little bit of time and decided to throw a charge on it, because we got down to about 30% charge remaining. And if I interpreted the indicators correctly, it was telling me that I could probably just turn around and go home with the 30% that I had. I kind of don't believe that, but it was telling me that I had charged enough to go home. But anyway, we started charging it. So we had like 30 minutes, 20 minutes to spare. So we went around. I have a ChargePoint app on my phone. ChargePoint is a service. It's like a search service for charging stations. And they also handle billing. So you register a credit card with them, and after that, you don't have to worry about credit cards. So I opened up my ChargePoint, and we found a charging station not too far away. And we dropped in on that. Happened to be in a mall. And heads up, you find them where people do park and go do other things, because, charging just takes some time. You just work it into your day, really. So you'll find charging stations at the mall, at the shopping center. We found them at Safeways. We found them at Whole Foods, just down the street from where we live. But ironically, they didn't work. Like, what's up with that, guys? Get your shit together. So, but the Safeway, well, okay, that's the end of the day. Earlier in the day, our first charging, we found a charging station at a mall. And it was sort of on the way back to where her appointment was. So we just pulled in there and charged for 20 minutes. The key here is you want to use the fast DC or DC fast charging mode. These charging stations come in basically different sizes. And some of them, will push electricity in at 220 volts, basically, split phase 220 at 150 amps, which is a lot of amperage. That's like 3 dryers worth of amperage. And it'll charge, it'll do a good job, but the ones you want are the fast DC. And DC direct current, I was noticing it was pushing 440 volts of DC, which is like hell on wheels. 440 volts is pretty much unpegged. And it was pushing 240 amps, which is gnarly. And it was really charging. I don't know, maybe you get 20% for this vehicle for its particular capacity. We were maybe getting 20% in 20 minutes. Maybe not 20%, because I don't think it was 1%. Well, maybe it was 1% per minute. And if you got 20 minutes, you pick up 20%. So that worked out really well. And so I like the looks of that. So we put 20 minutes on it, and then we went to her appointment. We came back. And then I can't remember. It was getting late, and I was getting tired. Actually, I wasn't feeling too well on Monday, and it turned out the week was really not a good week for me. My voice is still kind of weak, and maybe you've noticed. But anyway, so I kind of wanted to go home. I wasn't liking the idea of getting home late. So we popped back into the charging station, put another 40 minutes or so on it. And we were paying, they're quite upfront what you pay. We were paying 64 cents per kilowatt hour. And in, like I said, 20 minutes, we were putting in 13 kilowatt hours total. So I think we paid $7 at one charging and $13 at another. And, maybe the whole trip cost more money for the electricity than it did for gasoline, but that doesn't really matter. We decided to do an EV, and so we were willing to pay a premium for it, which also included the time it took to charge the vehicle. That was our decision, and I would absolutely do it again. It was a very good experience. Definitely 4 out of 5, maybe 4.5 out of 5 stars overall. And then, like I said, it was getting late, and I was getting tired, and I wasn't wanting to be on the road late at night, so we decided to come home. And I think we stopped, like I said, put in another $13 worth of electricity. And then like halfway home, I think we got to Gilroy. And there was another big charging station installation. It took us a little while to find it. Because like I said, these things are always poked away in weird places. But they are associated with malls and shopping centers and things like that. So we found another one. We used our ChargePoint app to find it. But it wasn't ChargePoint. It was Charge America or something like that, Charging America. And but we found it, and again, it was fast DC. So we put another 40 minutes in it or 30 minutes or something. There were some people parked next to us. We visited with them. Also rookies at renting EVs, and we got to compare notes. And got a good charge on it in Gilroy, and then kind of cruised home because we were pretty close to home at that point. I needed to turn it in the morning, like before 9 a.m. or 8 a.m., and it needed to be charged up to the level that they gave it to me, which was 96%. So our experience with charging suggested it wouldn't take more than maybe 45 minutes or an hour. But the truth is, we had trouble finding a charging station. There's a bank of charging stations pretty much across the street from our house at Target. But there were Tesla charging stations, and we thought, well, maybe are generic enough that they'll just work. Well, they're not. So we fiddled around with that and wasted some time there, and that was disappointing. But then I got back on my app and did some more searching, and I think maybe even I wanted to try the ones at Whole Foods because it's near our house, and I knew they were there because we shop there, so we see them. So we drove to the Whole Foods, and they were fucking broken. Unbelievable. So we messed around with those and got stuck, and I couldn't get the thing out of my charging port and all this bullshit, and wasted some time there. And finally found out that the Safeway nearby also had some charging stations, and we went over there. Found exactly what we needed at the Safeway. Again, not too surprising. Shopping centers, shopping malls, places where people are going to do something else, right? You go to the restaurant, plug your car in, go inside, have a nice meal, come back out, your car is charged. Or nearly so. So, now, we're paying 64 cents per kilowatt hour to charge this beast. Here at the house, we pay 23 cents a kilowatt hour. So if we had our own EV, and I didn't mind buying a charging station, which is what you kind of have to do, charge your EV, then I could have a 220 charging station, probably pushing, 150 amps or something, and I could charge it at home. And if it takes 6 hours, I really wouldn't care because I'm paying 23 cents an hour. I think my peak is like 25 if I go over my baseline. So, if I owned one of these things, this would be much, much easier. The fact that we're renting, we have to take it home, take it back in the morning when we get home, and there's all these requirements that it be charged, and, it just complicated things a little bit for us. But it was our choice to rent an EV, and I don't regret that at all. And we do have to go back for this procedure that she needs done, and if we do, we'll rent another EV. We'll rent this little Polestar 2 because it worked out just fine. In the neighborhood, walk to the Hertz, drive away and come back and take it back in the morning. The alternative, by the way, is kind of a pain in the ass. I wouldn't take my truck on a drive like this. It's really old. It could break down. It's not really comfortable either. Doesn't even have a heater. So I wouldn't take my truck at all. And plus, it gets like 10 miles to the gallon. But if you're going to use mass transit in lieu of an EV, that means basically, what is it? Well, it's not Caltrain. You could get to Gilroy with Caltrain, but that's not what you need to do. It's Amtrak. Yeah, thank you. Having a senior moment there. Amtrak. But basically, as a practical matter, you'd have to leave the day before just to get to Fresno on all the different connections you'd have to do. And rent a room, probably, and then go to your appointment the next day, probably. And you can't even catch an Amtrak coming home. If you're trying to make your appointment, depending on how that all works out, you might have to rent it, go back to 2 nights in a room, hotel room, and then come back in the morning on Amtrak. It's just annoying. But we're not going to drive a gas-powered car. My truck isn't cut out for it, and I'm not going to rent a gas-powered car to do that. I wanted to do it with an EV. So we did the EV thing, and it worked out fine. It really did. And I would do it again. And now that I know what I'm doing, what to expect, it should be much, much smoother. And get home before it's too late in the day. So that was my experience with an EV. The Polestar 2 is a nice little car. Very efficient with electricity, plenty fast, roomy enough for, definitely 2 passengers. I think you could probably get 4. It has a back seat. It looked really small to me, but you could probably get 4 people in it. Some degree of comfort. And then, the hatchback, you have some space behind the back seats. So, worked out fine, and would definitely do it again and recommend it for people who want to maybe try an EV, rent one, go on a little trip, and figure out how to use your ChargePoint app to find the charging stations. Again, fast DC, that's it. That's the name of the game. If you can't get a fast DC or DC fast, then don't bother. Because that's the only way to do it. Unless you're really going to be in the mall for 2 hours, because that's what you really have to do. For fast charging, like 30 minutes to get a good charge, then there's no other way to do it. So that was that. I just want to mention that. I'm kind of excited about it. I had a good experience. Now, back to the bad news. 2 things have been happening in the news lately. I think I'll talk about this one. Record-setting heat waves are baking the Arctic region. Now, this article, this Washington Post, and this image actually come from a while back. What was the date line on this? August 13th, 2024. August 13th, 2024. But I've been watching... Okay, record heat waves. Okay, how to do this. I watch a YouTube channel called Max Velocity, and he talks about severe weather. And he has almost a daily broadcast if there's severe weather. And these days it's daily. There's a clue phone for you. Daily extreme weather. And he was showing temperature anomalies in the lower 48 and associating these with severe weather. Temperature anomalies means that it's a calculation. It's not measured from a thermometer. It's a calculation. And what you're calculating is for the given temperature today in a station or a region or whatever, how does that compare with the weather, the temperature you'd expect on this date at that time, at that location? So if it departs, if it goes above, then that's anomalously high. If it goes well below, that's anomalously below temperature. So temperature anomalies are not absolute, they're relative. And if you look at this animation right here, you'll see that, let's see, what is this? Greenland is at the top, the North Pole is actually off the top of the chart, and Alaska's to the left, and the lower 48 U.S. states are cut off really at the bottom of this chart. This is mostly Canada, and a good part of this image is near or above the Arctic Circle. Now, there's several kinds of colors on here. The green and the blue are anomalously cold. The white colors are normal temperatures. And the red, well, yellow, orange, red, and then this weird salmon color, because they run out of red, tells you how bad it is. After red for really hot, they have to go into salmon and then white again. Well, don't kid yourself. White doesn't mean normal in this case. White means off the charts. And these anomalies are off the charts hot. Again, the temperature itself could be really cold. This is northern Canada, the boreal forest. This is maybe above the Arctic Circle. So there's even temperature anomalies on Greenland, which is the upper right-hand corner of this. It means that the temperature with these air masses that are moving from left to right are hot compared to what should be happening there. Now, this was back in August of 2024. Of course, August is summer in the Northern Hemisphere, so you wouldn't be too surprised. But really, you should be surprised because the Arctic is always cold. And it's really hard to get heat up there, even in the summer. So to have anomalously hot, meaning exceedingly hot temperatures in the Arctic, that's a big deal. And maybe it's not a big deal to you because you're not up there. But for the people who live up there, they're feeling it. They're understanding that. It's also melting a lot of ice, probably. It could be 70 degrees up there. 70 degrees, well, that's not very hot in August. It is if you're above the Arctic Circle, my friend. 70 degrees is fucking hot, okay? That's crazy hot. It's melting a lot of ice. And these anomalies on Greenland, these red and orange bands on Greenland, that's hot. That's melting ice. And so these high temperature anomalies were showing up in August, but the point of this was that I was watching Max Velocity, a YouTube channel who talks about, like I said, extreme weather. And he was talking about temperature anomalies in the lower 48. And just at the top of the map that he was using, that's not this one, because this is showing Canada and the Arctic. He was showing the lower 48, but it's the same map, just lower down. And he was looking at the map and talking about the anomalous high temperatures in the Gulf of Mexico and the southern states and the Southwest. I was like, dude, Max, would you look at those temperatures at the Arctic Circle? Because his map he was using just covered a little bit of Canada. And so just at the top of the map that he was showing us and pointing to Colorado and Wisconsin and Florida, there was this band of super anomalous temperatures. It doesn't mean super hot. It just means super anomalous, super hot for that region for this time of year. And this, like 2 YouTube videos in a row, he just completely ignored it because he's talking about weather conditions in the lower 48 U.S. states. And I was thinking, damn, Max, you should say something about that up there because I know what that means. I know exactly what that means. I know exactly what's going on up there. This has been going on for a half a decade in a huge, big way. And he was ignoring it. Well, finally, on one of his videos, he said, oh, and notice. So I think someone got to him. I think someone either called him on the phone and said, Max, maybe you should talk about what's happening around the Arctic Circle. He's a meteorologist. He's actually going to college to get his degree in meteorology. Meteorologists, I got to tell you, are piss poor at this. I don't know what the problem is. It's almost like it's a conspiracy. You can't find a meteorologist who will talk about what's happening with global heating. You just can't find them. And when they do, it's sometimes disappointing to somebody like me who really understands what's going on, and they're like waltzing around it. It's like, dude, just say what's happening. You're trying to address climate change. Just call it global heating and get on with it, right? So So Max came on and he said, one of his later videos, and I was watching it and I was seeing record high temperatures, the Arctic Circle. Well, Max, I was thinking, you should say something about that. And he did. He actually, a meteorologist came out and said something about it. Like I said, maybe someone got to him and said, Max, what are you going to say about this? And so he did. He said, yeah, this is record high temperatures. He called it, to paraphrase, record-breaking temperatures in the northern part of Canada and the Arctic Circle. Record-breaking temperatures for that place. Now, that doesn't mean you would find it comfortable. You could go up there and get off your airplane and you'd be wearing your t-shirt and shorts and sandals and freeze to death within 5 minutes, right? You might actually get hypothermia. But to the people who live there, they're probably noticing that it's really hot. And they might be wearing t-shirts and shorts, given the weather for them. You probably wouldn't, but they might. And once again, what's happening up there? Why is it record hot? Why has it been for 5 years? And why are we getting these record heat waves above the Arctic Circle, around the Arctic Circle, in the dead of winter? It's November. And, a week ago, he was pointing out record high temperatures in the Arctic. What's going on with that? A normal meteorologist wouldn't even have maps like this. A normal meteorologist who isn't interested in climatic issues whatsoever will just tell you where it's going to rain, record temperatures for major cities, Chicago, New York City, whatever, Cincinnati. And, they'll talk about that and then they'll just gloss over anything like this. They won't even show you a picture like this. Temperature anomalies. Most mouth breathers wouldn't be able to figure this shit out, okay, to save their lives. To save their lives, they couldn't figure out what this means. If they had to, if to save their lives, they couldn't do it. Because this is actual science. Temperature anomalies, departures from reality, departures from normal. Yeah, that's a big deal during a period of climate change and global heating. Yeah, departures from normal. You wouldn't expect that, would you? Well, you're getting them. And you're getting them all the fucking time. And they're a big fucking deal. The departures from normality are breaking us. Breaking us. We are being broken by this. Now, you don't live in the Arctic. You live in the lower 48. Well, here's the bad news for you. It's all tied in with these record high temperatures in the boreal forests and the Arctic Circle. This is 2 pictures of the Earth focused on North America. Of course. But this is a global phenomenon because the Earth is a globe. It is round for practical purposes. And what I'm showing you here also applies to Eurasia. The picture on the left is the normal, meaning up to about 10 years ago. The normal expectation for winds and cold air masses in the northern hemisphere most of the time. And what we expect is we expect things to be really super cold at the North Pole. And we expect things to be temperate below the Arctic Circle. And at about the point where the Arctic Circle is, maybe a little bit south of that, there's a thing called the North Polar Jet Stream. I'll just call it the Polar Jet Stream. There's also one in the south, but no one cares because no one lives down there. The Polar Jet Stream, that's of interest to us, acts as a ring fence. When the Polar Jet Stream is running hot, fast, which means like 400 or 500 miles an hour, it creates a wind on the ground, at ground level, that acts like a fence to trap the cold air north of that fence. The air could flow south except for this ring fence of fast-moving air that blows around the North Pole. And our weather then becomes local phenomena because the cold air is trapped up there and it seldom comes down. Now you can get bends and kinks in the jet stream. But even the ones that came south back in the good old days, before all this baloney started, they would maybe make it into Canada, maybe North Dakota, and they wouldn't really descend very far into the lower 48. They were not phenomena except in the far north, 60 degrees north latitude and higher. And those of us living down around 30s and 40s and 50 degrees latitude wouldn't even notice. sometimes the jet streams would dip south, or there would be a wave in it that would come further south and we wouldn't even notice. Meaning that the meteorologist never really had to deal with it. We had cold air associated with winter. We had cold air, but we didn't have these Arctic air masses coming down because the ring fence would keep them trapped. Well, about 10 years ago, that started to change, and it started to change like really fast. It was like 1 year things were groovy, and 2 years later, what the fuck? What just happened? What was that about? And for people who understood the behavior of the cold air mass trapped at the North Pole, what they were seeing was that parts of that cold air mass were breaking loose and coming down in huge volumes of air. Air masses the size of continents was slipping off the North Pole, just slipping down, like your hat falling off your head, just slipping down and coming down into the lower 48 and causing massive cold air anomalies. Just so cold it was unbelievable. And then it would happen again, and then it would happen again. And these weren't one-offs that happened every 10 years or so. These became 2 or 3 times, 4 times a year events. What the hell? And they knew what was happening. The meteorologists did not. The meteorologists kept talking like it was local weather, but it wasn't. It was cold air masses escaping the ring fence in the north, breaking through like a herd of the rampaging bison and slipping and falling south. And then eventually, moving east and disappearing into Europe, where, caused more problems in Europe. And so, people were kind of scratching their heads like, what's going on here? And of course, we were experiencing global heating. And so that's another head scratcher. Aren't we supposed to be experiencing global heating? Why do we have temperatures 40 degrees below zero in Colorado? That doesn't make any sense. And so they were looking at it, and they couldn't make any sense out of it. And they were still calling it weather, and it wasn't weather. And so there's this woman named Jennifer Francis. I'm pretty sure she worked at NOAA at the time. Maybe she didn't work at NOAA, but she does now. Jennifer Francis. And not a climatologist, not a glaciologist, not a cryosphere scientist, not an atmospheric scientist. But she did work in weather, but she was a statistician and a mathematician. And statistics and mathematics is a big in meteorology. All of your 5-day, 10-day forecasts are mathematically estimated. So she was working with NOAA. And she says, hold on, I think I understand what's happening. So she did a bunch of analysis. And that takes us back to this picture. The rapid and undiscussed but inevitable heating in the north. This is a big deal, people. This is huge. This is absolutely ginormous. This is changing everything, what's happening up to the north. This is basically the end of the world. And maybe if I have a chance at the end of the video, I'll explain why. This is the end of the human world. This is it. I don't know how to explain it. And this was its first manifestation. What happened was the jet stream that was supposed to be corralling that cold air to the north broke. The jet stream broke. 400, 500 mile an hour winds turning in a circle at the North Pole. It's been doing that for eons, millions of years. Started to break down. And so she did an analysis. She says, yeah, this is caused by a breakdown of the jet stream, the polar jet stream, and problems with the polar vortex. And what's happening is that the winds that create the jet stream, the 400, 500 mile an hour winds, are weakening. They're weakening because of the heating that's happening in the Arctic, which no one is up there to pay any attention to. We know these things because of satellites, and a few people up there with weather stations. And the rapid and catastrophic heating in at the North Pole is not staying at the North Pole. It's weakening the jet stream. The winds that make the jet stream go are caused by differentials in temperature and pressure. And that means that what used to be a very cold north and a very warm south, that created the jet stream. But as the north is warming, yes, the south is warming too, but not nearly as much as the north. As the north is warming, the differential between the two regions is decreasing, and that's causing the jet stream to slow down. Now, slowing down, well, what difference does that make? It's still going in a circle. No, it doesn't. And again, these are really hard problems to solve. She did the science of this phenomenon an enormous service, because she did what we call integration. She did scientific integration. There are people who specialize in ice, specialize in ocean currents, specialize in wind currents and jet streams, specialize in reflectivity, and specialize in heating, and specialize in modeling. And these people never get in the same room and talk to each other. And so she kind of did that. She, being a mathematician, and I don't know, a woman, she didn't know what her boundaries were. And so she just kind of figured it out. And she came back with this observation. It's not really a theory because it was just based on data. It's just observations. That the extreme heating in the north that no one was really paying any attention to except the people who lived in the north or who were studying the ice, which was melting, right? It was like, oh my God, the ice is melting. And that's a problem too. The ice melting is a big problem for those people. No one was putting all this stuff together. And so Jennifer Francis got on her computer and put it together. And when she came out with her observations that these things were correlated, that there was a mechanism here causing the jet stream to slow down and the slowed down jet stream to meander, okay, people thought she was full of shit. They basically told her. Again, why? Because she's a woman? Because she's a mathematician? I don't know what their problem was. Go sit in the corner and play with your toys. And I was absolutely appalled because I understand exactly what I understood at the time. The first time I heard her basically her thesis about what had happened, I was like, oh, hell yeah. Damn, she's right. And because she's right, we're kind of really fucked. And all these people were like, Jennifer, you're very sweet. Just don't bother us right now. The adults are having a conversation. And the problem is this. When you slow down a river, whether it's a river in the atmosphere or a river on land, like the Mississippi River or whatever, when it slows down, it doesn't flow in so straight a line anymore. When it slows down, it begins to meander. And rivers that are on an incline, in a landscape that has a good incline, will flow straight. They'll flow right down a canyon. They'll make their own canyons. They'll just flow straight. But when they get to the flats and they slow down, then they start to meander. And anybody who studies hydrology and river management will know exactly what that means. I used to live next to a river. The meanders in the river were just extremely annoying. What the kind of problems they caused. So a meandering river is a phenomenon of slowing down. And so what she said was, look, the jet stream is slowing down because the differentials are varying and decreasing. And so we don't have a steep gradient, which makes a fast jet stream. We have a shallow or even a flat gradient, which causes it to meander. And when it meanders, it slows down. Or I should say, when it slows down, it meanders. And her observation was that these meanders have implications. We've relied on the fast-moving ring fence to keep cold air locked into the North Pole. If you want to avoid the polar air, don't go up there. You'll be fine, right? Just don't go above the Arctic Circle, and you'll be fine. The cold air is only up there. It's not down here. It's up there. It never comes down here. If you want cold air, go up there. If you don't want to have cold air and you want to avoid 70 degrees below freezing, stay down here. But what happened was, the ring fence began to slow down. And as it slowed down, it began to meander like any other river does. And then what happened, and you see this in the second half of this diagram, the implications of this cannot be overstated. This is the end of our world. You have to understand the importance of this. When we have catastrophic, record-breaking heat in the north, it's still cold for what you're used to, but it's not cold enough to make the jet stream go fast, okay? It's breaking down. Then you get these meanders. And these these ridges, which are in red, and these troughs, which are in the white arrows or the blue air, right? The cold air. These are air masses. These are air masses. This is no longer local weather. When you have a huge ridge that's pulling up into the north, then it's pulling hot air from down below. Now you're getting hot air. You're getting air that should be in Cuba or the southern half of Mexico or something like that. It's being pulled up into your lower 48 states. And at the same time, you have a trough that's coming down right behind that. It's pulling down cold air from the Arctic. This isn't local weather. This is cold air from the Arctic. This is cold air from the Arctic. It's not local air. It doesn't belong here. If you could go to the Arctic and fill the air with like some sort of harmless pink smoke, then what you would be getting down is pink smoke. It's Arctic air. It's not local air. It doesn't belong here. It should be up there, and now it's down here. And maybe it warms up a little bit on the way down, but of course it's already record hot up there for what they're used to. So even when it comes south and you're thinking, my, this is really cold air, it's warmer than it should be, but it's also not where it's supposed to be. It's warmer than it should be, thank God, but it's not even where it's supposed to be. It's supposed to be up there. Now it's down here. And as the record heating begins in the Arctic, and as it continues, as it must, this cannot be altered, then the wavy nature of the jet stream is going to pull that cold air down, pull it down. And the implications of this are that you can go, and this is what's happening in our actual weather. If you're not paying attention to severe weather, people like channels like Max Velocity, which I highly recommend you check it out. He does a great job dealing with severe weather. And he doesn't always talk, he never talks about climate. So he won't offend you if you're a denialist. But he talks about severe weather, and you're going to see this. You'll be exposed to what's actually happening, even if he won't talk about it. You're going to be exposed to it. These cold air masses can cause massive, massive problems. We're not used to this. This is not our weather. This is not our atmosphere. This belongs above the Arctic Circle. And prior to global heating, it would have stayed above the Arctic Circle. But now that we have global heating, it can now escape from the Arctic Circle. And Max, when he shows a similar map to one I just showed a little bit ago, he shows the same map except focused more on the lower 48 states, which are below the fold here. When he shows this same map, he shows the ridges and the troughs marching across the country. And you end up getting record heat in one part of the country and record cold in the other. And then they change places. The record heat moves to the right, moves to the east, and the record cold moves to the east, and basically you go from record hot to record cold, because these are not local weather. These air masses are not local weather. The jet stream is pulling these in and depositing them on our heads. And this is not local weather. There's nothing local about this. We're screwed. This is really bad. And this is how the world ends. And how does this end the world? Because you go from one extreme to the other. The Great Lakes have a hard time freezing over when you have these record high ridges where the temperature anomaly is 20 degrees warmer than it should be. The Great Lakes have trouble freezing. That has implications for states east of the Great Lakes because the winds blow from west to east. When the winds come over the Great Lakes, if they're liquid, then the wind picks up moisture and blows it to the east, and you can get rain and even snow in the New England states east of the Great Lakes. When the Great Lakes manage to freeze over, then that stops because the wind blows over the ice. It doesn't pick up anything. Maybe a little bit of sublimation, but really the dry air, the cold air that's coming in from the northeast flies over, comes in over the Great Lakes, doesn't see Great Lakes, just sees an ice field, and it heads east, and it's just cold, dry air. We've had some, but because the Great Lakes aren't freezing, and because the Great Lakes aren't freezing nearly as soon as they should or as thoroughly as they should because of these warm air masses in the troughs, ridges. And then all the ice is melted from some ridge that came in for a week and melted everything. Then behind it is this cold air mass coming in from the Arctic Circle. And it's freaking cold. And so now that cold air mass passes over the Great Lakes. What does it see? It doesn't see an ice field because the warm air ridge melted all the ice or didn't allow it to form. Instead, it sees warm water. And it picks up all that moisture through evaporation. And it freezes it into snow. And then you get, I don't know what it was, 50 feet of snow in Buffalo, New York. Whatever the hell it was. They're getting storms. They're getting snowstorms now that just completely defy comprehension. And then they're saying, well, that's the end of global heating, I guess. No, it's caused by global heating. It's caused by that. Last week you had a record high temperatures, anomalously high temperatures. You were all out in your Hawaiian shirts and sandals, okay? And you were thinking, wow, we love this weather. This is great for northern New England. And then what you didn't know is because that ridge was a temporary phenomenon, and right behind it is a trough that represents freezing air from the Arctic. Arctic air is colder than you can possibly imagine because it's not local air. It came to you from an express bullet train from the Arctic. And now you're frolicking in the warm sun and the beautiful weather, and a day later you've got 50 feet of snow. You've got 50 fucking feet of snow. And what's that about? I go from anomalously warm to anomalously cold. Oh, and by the way, I got 50 feet of snow. Yes, it's all the same thing. It's all the same phenomenon. It's not going away. There's nowhere for it to go. It can't stop. It's always going to be like this. Well, no, it won't always be like this because it'll be getting worse. It gets worse from here on. Now, all of this is heading in a direction. And this is important to know. I heard, I think for the first time, maybe this year, 2024, that we have entered meteorologically, climatologically, what is called a terminating event, a termination event for the climate. We have ended the ice age. We have put so much CO2 in the atmosphere from burning fossil fuels, and that CO2 is there, capturing heat, that's the greenhouse effect, that we can no longer have an ice age. Before we did all that, there was even talk that, oh yes, by the way, because of the Milankovitch cycles, we'll be heading into a new ice age in, I don't know, 5,000 years, 10,000 years. It's kind of funny to think that far ahead, but hey, the Milankovitch cycles are completely predictable. It's math. You can predict it in a spreadsheet. So yeah, once we go into the next Milankovitch cycle in a big way, we'll be back in an ice age. And of course, that's interesting because that means the Laurentide ice sheet will extend down to what? Kansas, and everything will be under 2 miles of ice north of Kansas. Well, that's going to suck. But, it's 5,000, 10,000 years from now. It's no big deal, right? Don't sweat it. We'll do something, whatever. Well, what we did was we enhanced the greenhouse effect. We burned fossil fuels, pumped the CO2 into the atmosphere along with methane and nitrous oxides, a bunch of other shit. Also, we don't need, but we got them now. And we heated the atmosphere. And we're, at 424 parts per million of CO2 in the atmosphere now. That's way above the 280 that we exited the last ice age with. Way above 280. And we are no doubt heading straight for 524, if not 600. And we've ended the ice age. We're in a termination event. We did that. Wow. Okay, that's a thing. We terminated the ice age. Wow. Now what that means is two things. It's 100 things, but two things to point to right away. There will be no ice on the planet Earth to speak of. Maybe some of the highest elevations of the highest mountains. Everest might still have ice. Mount Whitney, maybe. I doubt it. Mount Whitney won't have ice. You'd have to go way north and find a really tall mountain to find ice on a planet that has no ice. There won't be any ice on Greenland. There won't be any ice on the Antarctic, the southern pole, to speak of. Again, maybe ice on the high ridges, but for the most part, there won't be any because we're not in an ice age anymore. You won't have glaciers, rivers of ice, right? You won't have permanent ice fields. And there was a time on this earth, whatever, I don't know, 100 million years ago, maybe even 50 million years ago, when there was no ice on this earth, except, like I said, in just really rare, out-of-the-way places. No ice. You go to Antarctica, the continent of, and you find the stumps, the petrified stumps of huge forests. You can't find that now, but you can. I mean, you can find the petrified stumps, but you can't find a forest. And yet, that's what's going to happen. Trees will return to Antarctica because they'll be melted. And they'll be cold weather trees because they do have a winter and a summer, right? And the winter is really severe and the summer is, 4 or 5 months long. The sun never sets. They'll have trees that can cope with that, but it won't be frozen. It'll just be really cold. It won't be frozen. There'll be no ice. Just be really cold. And every year the ice will melt. And every winter you'll get some snowfall probably, or some frost or whatever. And maybe some of the rivers will freeze, and that'll be all that happens in Antarctica. And then the summer will come and it'll all melt. That's called terminating the ice age. We're now in a termination event. We have enough CO2 in the atmosphere to have a termination event. Now the extension of that is, and I just alluded to it, the extension of that is that the temperature difference between the equator and the poles, let's just stick with the North Pole, that's our current example, the temperature difference will be really small. 20 degrees? Yeah, maybe 30. And so if it's 120 degrees at the equator, maybe it's 100 degrees, maybe 90 degrees at the pole. You wouldn't really even notice the difference. And that's where all this is headed. The look at the left side of this image. When there was a big difference in temperature between the North Pole and the equator, you had a strong jet stream. As the difference in temperature, the relative temperatures between the north and the south, well, not south, central, between the North Pole and the equator, as that difference decreases, which it is currently doing, the jet stream starts to weaken. As the difference between the temperature at the North Pole, Arctic Circle, and the equator decreases further, so that maybe most of the time it's 100 degrees, then it becomes 70 degrees different, then it becomes 50, then it becomes 20, as it continues to decrease because of this bullshit, right? Record high temperatures in the north. Don't imagine that doesn't have any meaning. Just don't even start to imagine that it doesn't matter just because you're not up there. This shit is a riot, okay? This shit is going to turn everything upside down. And when it does, it's going to completely destroy the polar jet stream. And there will be no cold air trapped in the north. And there will be no cold air descending down into the lower 48 states and fucking with your weather. Because there will be no cold air. It'll be gone. It'll be gone. Because of this bullshit. Record high temperatures in the Arctic Circle. That's a thing, people. That's reality. You may not want to look at it. You may want to avert your eyes. You may think it's a hoax. This is satellite data. This is satellite data, buckwheat. You better get your big boy pants on because, man, this shit is coming. And we are going through a period right now of intense gyrations in the weather, which the weathermen don't want to talk about because it's driven by global heating. This isn't even climate change. This is just an interim period. Eventually, we are going to start becoming hotter and hotter. When the ice in the north is completely gone, for all practical purposes, which could be anywhere, 20, 30 years, when the ice in the north is essentially gone, then these cold air masses don't exist anymore. They just don't, they're not there. How can they be cold? There's no ice. And then all that hot air that has been working its way north, will have no work to do. It'll just stay hot. There's no cold air to mix with. There's no ice to melt. There's no work to do. And it just keeps getting hotter and hotter and hotter. And the hot spot keeps moving north slowly and slowly. And eventually, the polar vortex is gone. the polar jet stream is non-existent. There's nothing to stop it. And pretty soon, we have heat waves going north and north and north and finally hitting the North Pole, melting all the ice. If there's any left. Whatever's little is left just vanishes. And then it attacks Greenland. And there's 70 feet of sea level rise in any significant melt of Greenland. 70 feet! Not 70 inches, not 70 millimeters. 70 feet of sea level rise in Greenland alone. This shit's getting real, people. Shit is getting real. Go watch yourself some Max Velocity on YouTube. And he'll show you. He won't talk about it, but he'll show you this. He'll just gloss over it. Oh yeah, those white, that's record temperatures. We're setting record temperatures in the north of Canada, but don't worry about it. It's the north of Canada. Hardly anybody lives up there, right? So don't worry about it. Yeah, worry lots, because this whole circus act is falling apart. Jennifer Francis brought it to our attention, and the climate scientists were like, Jennifer, girl, this is not your sandbox. Please don't, and these days they're like, oh yeah, right. She was right. Yeah, Jennifer Francis, she needs to get the Nobel Prize. Yeah, well, she helped us understand why this is happening. Boy, this sucks. This is bad. Jeez, we got to do something fast. And why do you think climate scientists are crying in their beers? It's because of shit like this. No, actually, because of shit like this. Crying in their beers, my dude. Crying in their beers. They know what's going on. I know what's going on. Oh, man. It's a coming. It's a coming. People aren't going to be able to cope. They're not going to be able to cope. They can't cope. There's no way. This is going to fall on people like a bear falling out of a tree. It's just going to hit you all at once. And it's going to maim you and break you and leave you terrified and scared and feeling stupid. And man, stop burning fossil fuels. You have to stop doing it. Max Velocity is not going to tell you that. And there are, you'd be hard pressed right now to find a climate scientist who's willing to tell you that. These people are running scared. They're worried about their jobs. They're already getting into territory where they have to say nothing but bad things. Scary shit. And they're just trying to protect their jobs. And they don't want to have any policy recommendations. They don't want to stir up any denialists. They don't want to get Congress mad at them. They got their collar turned up and their head down, and they're just kind of trying to stay out of trouble. And they're not going to tell you to stop burning fossil fuels. No, they're not. I'll tell you. Listen, monkey, you better stop burning fossil fuels. I got another reason for you to stop burning fossil fuels. They're going to shut down the fossil fuels. They're just going to do it. And do you think the elites care about you? The elites don't give a fuck about you. They care about themselves. And when the cheese gets binding and when this shit starts to go down, they're going to start looking at their Earth dynamic system, and they're going to have a big conference, probably in Davos, like they always do. And they're going to have to get together, and they're going to be smoking cigars and drinking expensive cognac and brandy, and they're going to say, yep, don't know. I guess we have to do this. We have to shut off the fossil fuels. That sucks. 300 years of brilliant economic growth and progress and innovation, and it's got to stop. I think they're going to do it. On my bleak days, I think that they're never going to fucking do it. But every time I look at this, and every time I look at things like this, all this bullshit unwinding in the far north, and I think about this thing that's been happening, and how resistant people were to this observation, this fact. They're just going to have to turn it off. There's no way out. They have to turn off the fossil fuels. And if on that historic day you're still driving yourself 20 miles to work or driving yourselves 10 miles to the big box shop to get your groceries, you are going to be well and truly screwed, my friend. You are going to be up shit's creek when they turn it off. And they're not going to do it gradually. They're not going to give you any clues. They're not going to give you time to go out and buy an AR-15 and 10,000 rounds of ammunition and go storm the Capitol. They're not going to give you fuck all. They're going to say, okay, turn it off right now. Turn it off. Don't give them a warning. Don't let them get organized. Don't let them get their dander up. Just turn it off. Turn it off. Sink or swim, bitch. We're turning it off. Oh, we just did. Sorry. Actually, we turned it off yesterday. So now you got to conserve your gasoline. You gotta go get your groceries. That's not going to last you very long. We're turning it off forever. And how long is it going to take you to get a garden going? How long is it going to take you to get a wheat field that you can till? And what domesticated animals you're going to have to pull? What plow you don't got? And you're going to have to get all this shit figured out. And you're going to be so busy figuring out your shit so that you don't die without fossil fuels that you're not going to be storming any capitals. You're not going to be waving any AR-15s in the air. You're not going to be popping off any rounds. You're going to be down at the fucking Home Depot buying every shovel they've got and all the seed. And you're going to be buying wheat seed bulk online from Amazon. And you're going to be tearing up your backyard. And you're going to be tearing up the acre behind your house. And you're going to try to find some way to till that. And you're going to buy your own private little tractor, little Kubota thing. And you're going to buy a little plow to go with it. And you're going to start tilling your acre in the back. And you're going to figure out when to plant the seed and how to harvest it. And you have to get another attachment for your four-wheel drive Kubota. And you're going to be too busy. You're going to be too busy getting your shit together because they just turned off the fossil fuels. And it took you about 72 hours to figure out that means you got nothing to eat. And what in your comfortable suburban existence ever prepared you for that day? And that's how they're going to do this. That's exactly how they're going to do it. And you can rage and scream right now all you want to. And they're going to wait till you calm the fuck down. And then they're going to do it. They're going to wait when you're all distracted with, the Democrats and Pelosi and AOC and Donald Trump. They're going to wait until you're so distracted you can't even think straight. And they'll push out some conspiracies, get you all wound up and get you in Twitter and Facebook and doing this on your keyboard. And they're going to get you all wound up. And then they're just going to sleaze out that shutdown. When you're all busy and hating each other and beating each other up in the parking lot outside the sports stadium, then they're just going to turn it off. And it's going to take you 72 hours to figure out what happened to you. It might even take you 2 weeks to figure out what happened to you. And then you go to buy gasoline, there won't be any. You go to another service station and they're down to the last drop. And you go to a different service station, they only have enough for, every other day. And pretty soon you got no gasoline. And then who are you going to beat up on? Then which capital are you going to storm? In which distant land? By what freeway? Yeah, you're not doing jack shit when they turn it off. You're not doing fuck all when they turn it off. Because you're screwed. You're done. You need to start figuring this out right now. You need to get yourself off of fossil fuels. You need to think about that as a serious project. How would I get off of fossil fuels? How would I feed myself? Where would my water come from? Can I rely on the electric grid anymore? How am I going to fix that? I got my own well on my property, but the electricity comes from wherever Egypt. What am I going to do about that? Well, I guess I can install a solar panel. It's hippie, it's communist, but I guess I can install a solar panel so I can run my fucking pump and pump my own water. Okay, so I got to buy solar panels. I have to install solar panels. I need, might have to, if the grid goes down, I still want power at night. I guess I got to have batteries and charge controllers. And fuck me. How am I going to do this? I'm starting to sound like a hippie communist. Yeah. I mean, if that's how you want to look at it, you're turning into a hippie communist. Okay, fine. Or you're just being smart. Because this is going to have to end because of, once again, this shit show. It's going to have to end. They're going to end it. They're not. They've only been sharing this planet with you. It belongs to them. And they don't want this to continue. Oh, they'll go on for a little while. It might go on for a couple more years, right? Yeah, 5 years. And at some point, the news gets so bad that they just have to sit down in Davos, the 10, maybe 20 richest men on earth with all the industries controlled by them and all the governments, really, certainly the G20. And they're just going to say, yeah, well, gentlemen, and they'll all be men, by the way, gentlemen, I think it's time. You want to vote on it? Does anybody disagree? Do we need to vote on this? Really? Seriously? I mean, we've had a nice run. It's been a good 300 years. And maybe we have enough money. So maybe we just would rather stay alive at this point. Because there's nowhere to go. Maybe, probably. I mean, you all got your bug out bag and you all got your private jet and you've all got your mountain retreat. But is that going to work? What if it doesn't? Maybe we should just turn out the fossil fuels and just let this play out. I think they've got really good survival instincts, people. And the 20 most important, 20 wealthiest, 20 whatever people on Earth are going to sit down in Davos with expensive cognac and cigars with their girlfriends sitting on their lap, probably. They wouldn't let any women in a conversation like that. With their girlfriends waiting outside, powdering their noses in the lobby. They're going to sit down in there and they say, well, gentlemen, we knew this day was coming. Shall we? How shall we? When? Next week? Sounds good to me. How do you want to do this? I can make a few phone calls right now and get the ball rolling. Shall we do this? All right, let's shut it off. That's one way this could play out. It's almost the only way this could play out. If they don't want to die because of this shit show, if they don't want to get swept up in the destruction of the Earth dynamic system, if they don't want to end up living on an island somewhere in the middle of the South Pacific, trying to survive with the rest of the loser chimps, well, then they're going to have to stop this. And they can stop this. They can. I know they can. They just don't want to. So far. Your responsibility is to survive when they turn it off. Your responsibility right now is to figure out how you're going to do that. Or don't. You don't have to survive. That's your responsibility, but you don't have to. People abrogate responsibilities all the time. Let someone else do it. Let someone else clean it up. Let someone else figure it out. I'm too busy. I'm too white. I'm too wealthy. I'm too middle class. Whatever it is. Someone else has to figure this out. Maybe they will. Probably they won't. It's your responsibility for your own survival. Figure it out. And you have to figure it out what it's going to look like without fossil fuels. Period. Now, my best guess is what it's going to look like is village life. And you can start contemplating how that works out in your region. Do you have land? Do you have friends? Are the people of a communal nature? Can you circle your wagons? Can you get people together? Will they ever come together? Are they always going to be independent, wild-eyed hillbillies? Or do you think people can work together to solve this problem of how you're all going to survive without fossil fuels? Can you even talk to these yahoos about life without fossil fuels? Or are they going to say you're just a wild-eyed hippie and, communist and just throw you out of the lifeboat? I don't know what they're going to do. But you need to start working on that. I think you got 3, maybe 5 years left in which to do that. Yeah, 3 to 5 years. It's not nearly enough. I don't know how you're going to do it in 5 years, at least of all 3. But yes, this is what's happening to you. Global heating. It's breaking everything. It's breaking everything. Everything is breaking. It's going to get worse. There are going to be parts of the United States of America that become uninhabitable. No joke. Uninhabitable. Not even joking. That's my rant. I drove an EV. It was good. Yeah. I've been talking about electrifying my truck. Sounds good. It's an expensive project, and it'll take my truck offline for weeks, if not months. And I kind of don't want to do it. But, I'll probably have to jump the shark on this one and just get in there and just do it. I've priced it. If I did it myself, basically with off-the-shelf materials and some small amount of machine work, although mostly it's off the shelf, I could probably do it for $20,000. You can't buy an electric truck for less than $60,000, $80,000. I can make a nice electric truck with my old antique truck, which happens to be a dump truck, thank you very much. So try to electrify and make a dump truck out of anything else. So my 1968 dump truck that I really like and works really well for me, I just yank out the 383 V8, probably sell that, and then start buying the parts to electrify it. I can do that. I bought a couple of books on it. I looked at it. It's not that big a deal. There's a certain amount of black arts to it and planning, and you have to kind of know what you want your range to be and how you're going to charge it and where you're going to charge it. And yeah, so I can figure that out. I can do that. And then when I have my electric truck with all the batteries in it, I can use that electricity to help power my home. So if I'm not using it on the road, it's actually a good backup battery supply for my, all electric house. So yeah, I'm probably going to do it. Will I do it this month? Next month? No. But I might this summer, right? I could do it this summer. Not a bad idea. Maybe I will. Maybe I'll do that this summer. Maybe I'll have some YouTube videos about electrifying my 1968 Dodge 1-ton dump truck. That'd be fun. Wouldn't that be fun? Leave a comment if you think that would be fun. Yes. Like the video. And if you want to hear more of this kind of stuff, you might want to click the subscribe button. I don't do this real often. Sometimes I get carried away and I'll do it every day for a week or two. But yeah, I'm kind of busy doing other things. It's winter and hard to get motivated. But anyway, here I am and here I go. So